What's up guys, welcome to my channel. In this video I'm going to teach you the first lesson in chemistry in this channel, and I want to apologize because I didn't upload a video for a long time. So let's get to the video. So the first lesson we're going to take in this channel about chemistry is about atoms and their structures. So I'm just about to show you the model of an atom. This is called a Bohr model. This model is a model found by a person called Bohr, and it's anticipated of atoms to look this way. So you can notice that there are two parts in this atom. It's the center and the part encircling it. So the center is called the atomic nucleus, and the atomic nucleus contains the majority or almost all amount of mass in the whole atom, and the ones encircling it are called the electronic shells. Let me just label them for you. So as you can see, it's labeled, and I'm going to show you as you can see, you've seen the structures of the atom, and I'm going to show you the more specifically about the atom. So atoms contain three subatomic particles. The three subatomic particles are proton, neutron, and electron. So the proton is a subatomic particle that contains a positive charge. So let me just show you the protons, neutrons, and electrons in the atom and how they are placed. So you might notice that I put stars over here. It's just to demonstrate that there are subatomic particles in an atom. So always note that subatomic particles are not shaped like stars. It's just to demonstrate it. So let's get back to the point. As you can see, that we have seen a subatomic particle in the atomic nucleus, and these are called protons. Protons are positively charged. So if the atom has more protons, then that means the atom is going to be positively charged. And protons are the only positively charged subatomic particle in the atom. So let's go to the next subatomic particle, which is the neutron. So a neutron is another subatomic particle that is found in the atomic nucleus, but the difference between a proton and a neutron is that a neutron is neutrally charged, so it does not have any charge. So we can notice that if there are more neutrons in an atom, there won't be any change because it won't contribute to the charges in the atom. So the neutron is found in the atomic nucleus, and I'm going to label it with stars again. As you can see, I've made blue stars for you not to be confused whether it's a neutron or a proton. So I'm demonstrating it with stars, but still note that none of the subatomic particles are shaped like stars. So the neutron is found in the atomic nucleus. As you can see, the blue stars are a demonstration for the neutrons. So remember that they're the only neutrally charged subatomic particle in the atom. So this takes us to the next subatomic particle in the atom, which is the electron. The electron is a negatively charged particle in the atom. It's found in the electronic shell. So let me demonstrate it using white stars this time. So I've put white stars on the electronic shell. So in here there are two electronic shells. It depends on the kind of atom. There may be two or more than two electronic shells, but for now let's just leave it with two electronic shells. So in here we know that the electrons are found in the encircling of the atom, which is the electronic shell, and they only exist in the electronic shell. They cannot exist in the atomic nucleus. And the thing I want to tell exceptionally about electrons is that they have the least mass. So we can we can notice that electrons almost do not contribute any mass to the atom. So we can now know that electrons have extremely little mass. So now I'm going to tell you, now that you know about subatomic particles, I'm about to show you more specifically about electronic shells. So electronic shells contain different amounts of capacity, which is the capacity of carrying electrons. So in the before atom demonstration, you saw that the first shell only carried 2 electrons, while the second carried 4 electrons. So I'm going to briefly tell you how and why that happened. Shells can be denoted in alphabetical names, which is the K, L, M, N, O, etc. These alphabetical letters are used to denote the electron shell in each place of the atom. So let me just write the electronic shells in here. So as you can see here, the K shell is the first shell. I'm going to draw the atom here. So you can see an atom with really big shells. It's because I told you that there are 5 shells, and I've put 5 shells in here. So each shell has difference in the amount of electrons they can carry. The first shell can only carry 2 electrons. The second shell can carry 8 electrons. The third one can carry 18, the fourth 32, and the fifth 50. So you may ask how I've known these. I didn't memorize them. There's a formula for finding how many electrons a shell can have due to its capacity. So the formula is 2n squared. So let's check it. I said that the first shell can only carry 2 electrons. So you might notice, what can I put in n? The place of n is we have to count on which place the shell is. For example, the K is at the first shell in here, so just have to put 1 and squared. So 1 squared is 2 times 1 squared is 2, because 1 squared is 1. So we just have to put 2 times 1, so it's 2. So it's confirmed that the first shell contains 2 electrons. The second shell contains 8 electrons. 2 2 squared is 4, and 2 times 4 is 8. So this one is confirmed. It keeps going. You can write it on a piece of paper, and you can write any kind of shell configuration in here. So let's say there is another 6th shell, and you can just put n and set n to 6, and then you can get the sequence. So, but know this: when you electrons can be useful for knowing which element is found in a group or in a period. So you can locate an element by finding the electron, or how many electrons there are in each shell. But you don't use the 2n squared in here. The first one will become the first shell. Look, the first shell will become 2. The second one will become 8. And you might say the third one will become 18, but it won't be. The third one becomes 8 again. But you use this if you only want to configure the location of an element. Okay, so that's it for the video. If you're new for this channel, make sure to subscribe, and if you like this video, make sure to like. I just want to reach 1K, so help me get to it.